Thank you. So yeah, my name is Sohan. I live in Amsterdam, have worked in the industry for 16 years now. So I've seen a lot of changes. And today I'm going to talk to you about security, authorization, AI, and a bunch of other things. Just as a point of note, I work in a startup called AuthZed, and we work with a large AI company that I'll mention towards the end. And what you'll see today are some learnings from that. So what you're seeing actually is in production. Now, some of you all might have heard of this thing called AI. I don't know if you may have heard of it. And I like to think of 2025, this year, as the year that all of us are putting AI in production. I work with a lot of enterprises, I work with cloud companies, and finally people, after trying out proof of concepts and experiments, are putting AI in production. And they're doing so via agents. We just saw the previous talk, via things like MCP and LLMs, and also this thing called a RAG. Now, if you're not familiar, RAG stands for Retrieval Augmented Generation. So this is when it's an architectural decision. So suppose you have a large corpus of documents, say 1 million documents, and it would be domain-specific knowledge, so something that maybe a regular LLM doesn't know about. So instead of training your own large language model just to read those documents, you can augment an existing LLM with these documents using something called a RAG. And we're seeing enterprises and companies use it both internally and externally for chatbots for, information that might be just in that domain. But what we're not seeing enough of is the security around who can access which of those documentation. Now, anyone here works in enterprise, you may have heard of this foundation called OWASP. Has anyone heard of OWASP? A few of you all, yeah, excellent, which means you'll have checked in code at some point of time in your life. And OWASP is an industry body. So every few years, they make a list of risks to web apps or risks to LLMs. And they came up with a list to risk for LLMs last year. And that included things like sensitive information disclosure, where you would ping an AI agent something, and it would give you information that it wasn't supposed to know. Or excessive agency, where you asked an agent to do something, but it did something else again that it wasn't supposed to. And also vector and embedding weaknesses, where I could add code into my vector database maliciously, and it would do something that it wasn't supposed to. And all of these can be addressed by proper authorization. So that's what we're here to talk to you about. And this is typically what a RAG pipeline looks like at a very high level. So all the way to your left. All the way to your left is this is the first phase of ingestion of documents. So you have a big knowledge base, millions of documents. You pre-process it, you clean it up a little bit. Does this work? Yeah, I don't know if you can see it, but you pre-process it and you send those documents into something called an embedding model, which creates embeddings. Very, very high level. Embeddings are a way to represent words and images in numbers, because computers like numbers. And those embeddings are stored in a vector database. And here's the important part. You can store metadata. So you can say that this embedding came from this document with document ID 123. And remember that, because we're going to come back to that. The second phase looks pretty simple and quite self-explanatory, which is the query, the retrieval, and response phase. So user at the bottom makes a query. And that query also goes to the embedding model. And that embedded query goes to the vector database. And you get all the relevant embeddings, which are then sent to a large language model, which gives a response back. The one thing that's missing from all of this is authorization or security. What if a user accesses some knowledge or some data from that knowledge base that they don't have access to? That's what we're talking about. So I'm going to give you a very quick primer on authorization. In the industry, sometimes people conflate the word auth to both authentication and authorization, and they're two different things. Authentication is identity. So when you log in, who you are, that's authentication. Authorization is permissions. What do you have access to after we know who you are? And in the past, way back in the past, we started off with something called an access control list. Think of it as a very long list of saying, document ID 1, these are all the people who can read this document. Now you have a new list for all the people who can write to this document. Not the most scalable way, of course, but we changed it around in the industry to something called a role-based access control. Again, you, I'm sure, have this in your company where you are tagged to a role like software engineer, and everyone in that role of software engineer can check in code. Someone else is tagged to a salesperson, and a salesperson can access finance reports. So you're putting people into roles, and roles can do things. Again, doesn't necessarily scale, because what if you have one person in sales who wants to check in code? Doesn't happen often, but it could. So it evolved to something called attribute-based access control, where everything is an attribute. So your name, your time of day, your email ID, your location, all of those are attributes. And when a decision has to be made, basically you check if all of the attributes match what is allowed and what's not, and a decision is made. Again, pretty flexible, but at scale can be difficult. Now, after the advent of social networks and sometime in the mid-2010s, Google basically decided that a lot of these don't necessarily scale for their levels of scale. Google has planet level scale, billions of users, millions of checks per second. So they rethought how they did authorization internally. And we know exactly how they did it because in 2019 actually, so it's quite recent, they published a white paper called Google Zanzibar. And this is going to be the crux of today's talk. And in this white paper, they describe exactly how Google does authorization across all of their services. If you've ever used a Google product, which I'm sure you have, then in the backend, this is how an authorization check is happening across Docs, Maps, YouTube, Photos, all of it. I would advise you to read the paper. It's about 14 pages and it's written in plain English, not very academic. It's a fun read. And it describes their internal authorization system, how back in 2019, it could do more than 10 million client queries per second. And I'm sure that number has increased even now. The cool thing is for a developer in Google, it's just an API. So you don't have to worry about how it works. And I'll talk about that. But it popularized this concept of RBAC, what you see there, which stands for relationship-based access control. So instead of everything being fit into a role or an attribute, everything is in a relationship from one thing to another. So for instance, you can have a user named Gru, and you have a folder named Evil Plans. There's a relationship between that person and the folder, in which case it's viewer. Now say there's a document called Steal the Moon. There is a relationship between the folder and the document, which is it's contained in the folder. And thereby, there's a transitive relationship between the person and the document. So everything is in a form of a relationship. So what can you have relationships with? Well, one is a user. Again, in Google, if you have an account, you have something called a Gaia ID. So that could be your Gaia ID. And that could relate to any object. It could be a folder, a document, a map, a YouTube video, and so on. And the relation could, again, be anything. It could be a member of a group or an uploader of a video or, an editor of a document. It doesn't matter. So you have a user, you have an object, and you have the relationship between those two things. So once you have that, you need a way to represent this relationship in a system. A computer needs to understand this. So Google described this thing called a tuple, a relation tuple. And the format basically is you start at the hashtag and what's on the right. So you will see user number 3 is an owner of document 123. So say I'm user number 3 and I create a document in Google Docs. This will be written to their authorization system. So that way the system knows that I am the owner of this document. And this is very flexible because objects can also relate to other objects, and objects can relate to other objects' relations as well. So for instance, in this, again, start from the right, the group security is a member of the group engineering. Now this gives flexibility for Google when things change. Imagine when you have a reorg at work and say suddenly group security reports to the group DevOps. Internally, there's a whole lot of changes for your LDAP and for your groups and so on. But in a Zanzibar-like system, it's just about writing a new relation tuple. So we have users, objects, we have relations, we have these tuples. What is done with all of this? Basically, the backend builds what is called a directed acyclic graph, which represents these users and the relations. So say you have a document and you have users. Fred and Kim are readers of that document, and Jill is a writer of the document. You will notice the key here is this little dotted arrow between reader and writer, which indicates that everyone who's a writer can also read the document, again, like in Google Docs. And this gives flexibility. Say suddenly you have to add an organization into this mix. You just add a new node to the graph like organization, and you say this is the name of the organization. You have an admin, say Niv, and again, look at the dotted line between writer and admin. So this indicates anyone who's an admin of an org is a writer of the document, and we know all writers are also readers. And anytime now, say a permission checks comes in. So say in the backend, at any time, if you have tried to access a Google Doc, this is probably what's happening. So the check comes for checking if Jill is a reader of some document, right? So Jill clicks on a document link. Do we know Jill has access or not? Basically, if you can traverse from the document to Jill in a unidirectional way, there is a relationship. So let's take a look. Here you go from document to reader to writer to Jill. There is a way to traverse. So the API returns saying, yes, Jill has read permissions. Similarly, if you want to check if Fred at the top has write permissions, there is no way to go from some document to writer to Fred in a unidirectional way. So Fred does not have permissions. So again, anytime you have accessed a Google Doc or any file on Google, this sort of check is probably happening on their system. And this is new, 2019. It really set the authorization and IAM world on fire, and lots of companies are, re-architecting their authorization for this because it is designed for scale and for low latency. It has to work at Google scale, and especially when things change a lot. The relationships between users and documents and objects change a lot, which is what happens. This Zanzibar-like system really shines. Turns out, a RAG pipeline needs all of these requirements. It's a lots of documents, it's users, it's low latency, and hence we're going to use a Zanzibar-like system to secure our RAG pipeline. Now, this came out in 2019, so there were lots of open source versions of Google Zanzibar. I think the most famous example of Google white paper going to open source is probably, can anyone guess? Is Kubernetes. So Kubernetes started off as Borg in Google as a white paper and internal system. And then, of course, people built an open source version, and now the whole world uses it. So right now, these are probably the 4 most popular open source versions of Zanzibar. There's SpiceDB, Ori, OpenFGA, and Permify. The company I work for helps maintain SpiceDB, so I'll show the demo with that. But it's an open source project with contributions from Red Hat, GitHub, Netflix, and so on. Feel free to jump in and contribute as well. And the only metric I think that matters to us as developers is GitHub stars. That's the only metric we check. So yeah, it has about 6,000 GitHub stars. It could always use more. So, nudge, nudge, wink, wink. And that's what I'm going to use in our demo. So what is SpiceDB? Well, SpiceDB is an open source implementation of Zanzibar. In a way, it's a graph database, and it's optimized for purely authorization queries. So if you want to build authorization into your app, you can use this open source thing called SpiceDB. And you can make queries in any of the client libraries, but internally, it's written in Go. How does it work? Well, there are 3 things you need to know. The first one, remember when I showed you the relationship tuples? Well, before that, you'll have to do something called a schema. Again, this is described in the Zanzibar paper, but a schema is a way to represent any use case. So your use case could be something like YouTube or like GitHub or even Google Docs. How do you represent the users, the objects, and the relations in them? Well, say you're building something like Google Docs or even a RAG pipeline. You have objects like a user and a document, and you have the relationships between them, like a writer of a document can read and edit a doc. In schema, basically, you're just representing it this way. You're defining the user and the document, the relation between the user and the document. So a user can be a writer or a reader. And if they're a writer, they can, read and edit a doc. If they're a reader, they can only read the document. Yeah, so you describe your use case within this schema. Once you have the schema, you can create, read, update, and delete relationships. This is what I showed you. So anytime a new document is created, you add a relationship between the document and the creator. Anytime someone is added to a document, you add that as a relationship here. So in this case, we have a reader who's Fred, a writer who's Jill, and suppose a new user like me, Sohan, is added. I will be added to, say, the writer of the document. And again, this additions is done via the tuple that I told you earlier. And lastly, you have to check for permissions, of course. We have a schema, we have all these relationships. When someone tries to access something, you check if they have permissions or not. So this is the same old graph that I'm showing you. So you can check for permission. Again, remember, unidirectional way from document to someone. SpiceDB also gives you lookups. So you can look up a subject and say, give me all the readers of some document. So it will traverse this entire graph and give you all of these names because all of these people are readers of the document. You can also do a reverse lookup and say, give me all the documents that Fred can have access to. So in this case, you would get some document, but in a real world scenario, this is a massive graph. So there's a reverse lookup in all of these documents. All right, so we have RAG pipelines, and we have a very new form of authorization that is well suited for RAG pipelines. Let's actually jump in and see how that would work. There are two techniques or two different ways you can do this, a pre-filtering and a post-filtering. So I'm going to start with something called the post-filter method. So far, so good. This is our standard RAG pipeline. You have an embedding, you have vector databases, and you have the metadata. Remember? Callback? Yes, you have the metadata in your vector database. Once you get that, you can actually use any Zanzibar-like system to run check permission requests on each of those documents that come from the embeddings. So say you get back 5 embeddings with 5 different document IDs, you can run a check permission request on each of them to see if the user has access or not. And say maybe the user doesn't have access to one of them, that's great. The other 4 will be sent to the LLM and a response is sent back. So this way, the user is not seeing any information that they don't have authorization or access to. So you get the embeddings, you look at the documents related to those embeddings, and then do a check permission request. Typically, you would use this method if you have a high positive hit rate of the user having access to documents. Say you have 1 million documents and the user can access just 2. This is a very inefficient process then. But say you have 100 documents and the user can access 90, this is the way to go. So when a post filter is inefficient, we have a pre-filter authorization where the user makes the query, and even before going to the vector database, you do a pre-filtration. So here, instead of a check permission, you are going to look up all the documents that the user can have access to. So you do that lookup request, you get a response, and then you send those embedded with the query itself to the vector database. So in the beginning, you're like, give me all the documents that the user can access, and I will only use those in the vector database, and then go to the LLM. Here, if you have a very large corpus of data, like 1 million documents, maybe the user can access 100, this is a much more efficient method. The demo I'm going to show you is this pre-filter authorization, and I'm going to show it with using Finecone as a vector database, with the OpenAI API, with SpiceDB as our Zanzibar-like system. But honestly, you can swap it out for any other tool. You can use a different Zanzibar-like system instead of SpiceDB. You can use pgvector or any vector database, and you can swap out any model. And I use LangChain to chain all of these. So let's go. If you want to, the entire demo in a Jupyter Notebook is on this link. So if you want to take a photo, maybe now's your chance while I get a sip of water. I'm also going to make a quick prayer to the demo gods because conference Wi-Fi's and demo, you know how that goes sometimes, but we will see. Okay, so this is my Jupyter notebook. I hope you can see it at the back, but yeah, it's good. All right. Okay, maybe I'll increase it a little more. So first thing is I have a local instance of SpiceDB running here on my screen. So it's running locally. Typically, of course, this would be running in the cloud. All this is just boilerplate code. But first, we start with defining our schema, right? This mirrors our use case. Super easy. We have a user and we have an article, which is in our RAG pipeline. And we need to define the permissions and the relations between them. So the relation is a user can be a viewer, and if they're a viewer, they can view it. This is the easiest possible schema. Of course, in production, you can add a relation of a user being a writer to this RAG pipeline, whatever. Right? So I'm going to run this. So I'm writing the schema, and you will see here at my system clock is weird. Don't mind that. But you can see a write schema request that's been made just now. Right? All right. So now what I'm going to do is I'm going to write relationships between some documents and the user. I'm assuming a user is logged in named Tim. And I'm just going to create two documents. Again, very simple demo. One document with ID 123, one document with ID 456. Right? So we have two documents, one user. Very simple. And we are adding the relation of viewer, right? So I'm just going to write that relation to my SpiceDB, and you will see these relationships have been written. Okay, so I've created a Pinecone index already as my vector database. You will see it here. This is my Pinecone database. I'm not going to create it again. And I have also added embedding. So these are my documents. Typically, this would be some, like an S3 bucket or OpenSearch where you have millions of documents. But for the demo, I've created two documents and I've added random stuff into it. I've said Bill Gates won the 2025 Oscar for Best Football Movie. There's no such thing. And the revenue, whatever. It was just for fun. But the important thing, the article ID of this is 123 and the article ID of this is 456. Right? And I'm just initializing a LangChain embedding where I've added these embeddings into my index already. So, I haven't. I'll just run that now. Yeah, so I'm just going to run that now, and that should write to my Pinecone database. Yeah, there we go. It's written to my vector database. So now I'm running that lookup request that I told you about, this step where I'm going to get the documents that the user has access to. So let's run that. And I get back from SpiceDB that Tim is authorized to view two articles, 123 and 456. And you can also see this permissions request that's being made, a lookup resources in my local SpiceDB. So now that I've got these two documents, I can actually tell my LLM what I need. So I'm defining a LangChain object to talk to OpenAI. Using an older model, you can swap it out to any model. And this is a Pinecone index with my OpenAI embedding model. I'm initializing a retriever with a filter. And this filter is the documents that I'm allowed to view. And this part here is just basic prompt engineering, where I say just answer the question using the context below. And the question I'm asking is, who won the Oscar, right? And that information is there in document 123. So yeah, it pinged the OpenAI API and it gave me that information, right, from that document. I can also do a summary. I can also do a summary of only the articles that the user is allowed to view. So right now, the user can view both articles. So I'm going to run a simple summary. Again, very similar things with the prompt engineering and some LangChain object. And you'll get, let me run this summary here. So yeah, it says Tim can view articles 1, 2, 3, and 4, 5, 6. And it's making a call to the OpenAI API and says, yes, in Q4 2025, the revenue is 1 billion. Additionally, whatever, right? So it summarized the two documents the user has access to. In the real world, these things change. So for instance, maybe someone has removed Tim's access to this article 123. So you can see I'm deleting this relationship between Tim and that article. That's what's running here. So I'm just going to run that. You will see here a write relationship call has been made. And we can actually check and see that, okay, right now Tim can view only one article, right? And let's make that call again. You say, okay, who won this Oscar? It's the LLM says I do not have context on this because Tim does not have access to that document, right? Earlier we asked the same question when Tim had access and we got information back. So that was basically it. Now, this of course is a very, very simple demo, 2 documents, 1 user, but I'm happy to tell you that this is literally what OpenAI uses for their connectors product. So recently OpenAI released a new product called Connectors, where you can connect it to Google Drive or Dropbox or a bunch of other tools, and you can query data from that. And they use SpiceDB, and of course at a much, much bigger scale. But all of it is basically just horizontal scaling. You have beefier compute, beefier databases, and so on. And yeah, they're able to process 37 billion plus documents and fine-grain authorization for each of these using what I just showed you. And you also have second-order effects where you do a thing, but there is another effect of the effect, which is one, you get audit logging for everything. So anytime a permission changes, you have to write that to the database. So that is logged. And of course, you're optimizing your query responses as well, because you're querying only documents that the user has access to. So you can also optimize your RAG pipelines at scale. Yeah, I think I'm almost done with time. So again, if you just want to take a photo, the first one is a link to the workshop. I suggest if you like things like distributed systems, read the Zanzibar paper. It's a Google white paper, very interesting. And yeah, check out SpiceDB. Feel free to jump in and contribute. It's open source. And yeah, I'm around for any questions. Also, feel free to connect with me on LinkedIn if you have any other questions. And hope you learned something new today. Thank you.